losing the internet. In fact, very famously, Bob Metcalfe, who was the guy who created Ethernet, said many years ago, the internet's going to collapse of its own weight any day now.
Well, the guy that designed DNS, a guy named Paul Makapetris, he says today he never would have believed this thing would have survived this long. It was, I mean, you know, all this sort of happened as a phenomenon that no one really expected.
No, it grew it grew, and they didn't know how big it was going to get.
And we talk about all the security problems that it's got. It's because it's like not ready for prime time.
Right. So let's explain briefly DNS, the domain name system. It's the kind of the big phone book where you enter in, callforhelptv.com, and it returns to you the actual address, the IP address of the server.
Say we got Joe User here,
yes,
and one of his applications needs to know Microsoft.com. What the IP is from the IP.
It's the server address. If he doesn't have the actual server address, he's never going to get there.
Right, and so he hasn't got that memorized, obviously, but he knows www.microsoft.com. So say that he wants to surf to Microsoft.com. So his application asks his computer. His computer checks to see whether it has it cached. That is,
does it know it already?
Exactly. Has he asked for it recently so that it's still in its cache?
Right.
If not, his computer has a DNS server that's been assigned by his ISP. So his ISP has a DNS server, so his computer asks the ISP.
Now this cache, just before we go too far, is in memory, but there's also the hosts file. Does it also check that?
It checks that first, actually.
That's a disk-based cache, in effect.
Sort of, yeah.
Yeah. And then it checks it in memory. And when you set up your internet access, you will often enter in those numbers for the DNS server that your internet service provider gives you.
If you have the obtain IP address automatically, the DHCP, it'll feed it into your computer and configure it automatically. So his computer asks the ISP's DNS server, do you know the IP address for Microsoft.com? Maybe the ISP knows. For example, if Alice over here had asked a few minutes before, then the ISP would have arranged to get it already, so it would still have it in its cache.
Very handy.
Because someone else recently asked for it.
So the idea is this is going to save extra requests. You don't have to do any.
And that's exactly the key. That turns out to be far more important than most people recognize. That is, this notion of caching is the reason the whole system still works.
What happens if the ISP doesn't know it?
Well, if the ISP doesn't know, then it says, wait a minute, I need to get Microsoft.com. It doesn't know where to start. So it makes a query of what's called the DNS root servers.
This is the master directory.
There's 13 of them spread around the world.
That's all?
That's all. There are only 13.
Okay.
And then we've had 13 for a long time. They're on the West Coast, the East Coast, and there's like a few of them in foreign countries. Okay. You know, Tokyo and in Europe and so forth. Okay. So the ISP asks the root server, where do I go to find the DNS servers from Microsoft.com? The root server tells the ISP what the IP addresses are for Microsoft servers. Then the ISP asks for the IP for the specific domain over at Microsoft.
Microsoft, and all websites do this, they run their own DNS servers that will do the final resolution.
Exactly.
Here is where the site is that you're looking for.
So that goes back to the ISP, back to Joe User's computer, and the answer gets returned to his app.
It's kind of amazing that this works.
Well, it does, but again, it's more fragile than people expect.
Because if we all asked the root servers all the time, it would be too slow.
That's exactly right. What happened a few years ago, Microsoft made a mistake, and there's something called this time to live that involves the caching.
You want this to change periodically because the address can change. So you don't want to assume that it's always good forever.
Exactly. Say that Microsoft did need to change their IP address to something else. Well, they don't want everyone to hold. So what would happen is the old one would get stale.
It takes a while to propagate down.
And that's called DNS propagation. Yeah. Normally, Microsoft would say, well, our IP is going to be good for a day. We'll say that it's good for a day, for 24 hours. And what that means is that this ISP that had Microsoft's previous IP, if Joe and Alice were asking for it, it would keep a copy, but it would notice how long it was taking to expire. After 24 hours, it would say, the last time I looked was a day ago. I better make sure it hasn't changed.
You have to do that, otherwise you can never change your address.
A couple of years ago, Microsoft had a configuration mistake where they lowered their TTL, this time to live, to 2 hours.
Normally it would be a day?
Normally it's about a day. Okay. A day is typical. Sometimes a week if you know you're going to be...
You're not going to move around.
You're not going to move around.
And who sets that? The individual websites?
Yes, it's just the configuration.
So my website has a TTL that would normally be a day. Microsoft set it to 2 hours.
They set it for 2 hours. Normally the load on the root servers for answering ISP queries for Microsoft is 0%. That is
because everybody goes there.
Exactly, but it's all being cached in these ISPs.
Yeah.
When Microsoft had it for 2 hours, the load slowly increased so that it was 25% of the load on the root servers just answering Microsoft.com queries.
It's one of the top 5 websites, so it has enough traffic that by just changing that time to live
down to 2 hours.
It was traffic overall on the internet to the root servers was up 25%.
The overall load on the root servers, 25% of it was Microsoft.
So what is the impact of this from the terms of reliability?
What this means is that, well, and we've seen worms, and we've seen some spam spreading worms have put a substantial load on the root servers that in one case crashed 8 of them.
Oh dear!
And I mean, literally, it was
they were out of commission.
They were out of commission, but the system was limping along.
Still had 5.
But you still had 5. So
that's why there's so many.
The redundancy solved the problem. It turns out that if somebody were to attack the DNS system, the IP addresses of these 13 root servers doesn't change. It almost can't change essentially
because it has to be there.
You know that's the root information.
You can't move the library.
If somebody were to use one of these bot networks, not to do just an ICMP flood,
should you be telling
but an actual set of DNS queries, they would have to maintain that attack not for a few minutes, but for a day.
Because you'd have to get the time to live.
Exactly. Essentially, you hold the root servers off for a day. The cached copies would expire throughout the entire internet.
And the whole internet would be gone.
The whole internet would shut down.
Period.
Yeah.
Nobody get anywhere.
Literally. It would
Unless you remember the address of Microsoft and typed 192.168.1.
If you happen to know what that was, you could put it in manually.
Maybe start building up your host file now, ladies and gentlemen.
I mean,
how likely is something like that?
Well,
period.
Yeah.
Nobody get anywhere.
Literally.
Unless you remember the address of Microsoft and typed 192.168.1.
If you happen to know what that was, you could put it in manually.
Maybe start building up your host file now, ladies and gentlemen.
I mean,
how likely is something like that?
Well,
have you just given away a big secret? Or is this widely known?
You can't fix what you don't know is a problem.
Right.
So we need to focus on the fact that we've already seen viruses and spam and misconfigured, accidentally and misconfigured important servers have substantially slowed things down. These root servers are completely vulnerable.
Is anybody addressing this?
No.
Is there a fix?
No.
Okay. The Gibson Research Corporation is owned and operated by the one and only Steve Gibson. Call him! You'll find it online at grc.com. I hope ICANN or somebody is paying attention to this. They know, obviously, this is an issue.
Well, they blocked ICMP because that was the last attack.
The ping of death.
And if you really didn't know what you were doing, or you used existing bot networks, you would just try to do a ping flood.
Right.
And that used to work. That's been blocked. But if you actually did DNS queries, there's no way to block that.
Because if you would then block, if you block DNS, it wouldn't work.
Right.
It's like saying I'm not on the job.
It's too fragile. It needs caching.
So if you're a hacker and you'd like to know more, go to the show notes. Call for LTV.com. Don't, please, no, please, we beg you.